Okay, today we will learn data flow diagram. What is data flow diagram? It is a graphical representation of the flow of data through a systematic picture, systematic picture as a network or function or process or algorithm. So this is the graphical representation of the data. Whatever data is available into your system should be available into your system. What should be the name of those data, and how this data is going from one process to another process. All these are been described into this through this data flow diagram. It is known as bubble chart, also known as bubble chart, and a simple graphical formalism. It is used to represent a system in terms of the input data to the system, various processing carried out on those data, and output data generated by the system. So DFD actually takes some input data, process it, and give you some output. DFD model represents the subfunctions performed by the function using a hierarchy of the diagram. The diagram, or that means the processes, are should be into an hierarchical structure in the DFD data flow model. Here are the basic symbols used for constructing the DFD. Keep in mind that we are using here the Jordan's notations normally. And there are so many other notations also available. You may found it if you check it into another book or another or in internet. So here we are processing. Here we are following the Jordan's notation. In this notation, the rectangle represents the external entities. A circle represents the process. A arrow represents data flow, and this symbol represents the output, and these lines represent the data store. Okay, normally these five symbols are used in this Jordan's notation to prepare the DFD. The first one is circle. It is the function symbol or process symbol. A function actually represented using a circle, and this symbol is called the process or a bubble to perform some processing input data. To process some input data, we use this circle. A function such as search book. Search book is a function. To searching, it takes some inputs and gives some outputs. So this search book represent uh, represented using a circle. Using a circle. This symbol is called a process or bubble or transform. Bubbles are annotated with corresponding function names. Here we should write the function names. A function represents some activity. Function means it is some activity. Here the activity is search book, and function name should be verb, obviously. Okay, so this is called process or function symbol. This is called external entity symbol. This rectangle is called external entity symbol. An external entity such as librarian, library member, etc. is represented by a rectangle. The external entities are essentially those physical entities external to the software system, which interacts with the system by inputting some data to the system or by consuming some data produced by the system. So external entities are those entities of the software system which interacts with the system by getting some value or by giving some value to the system. So these are called external entities. And it represented by a rectangle, obviously. External entities are either users or external systems. input data to the system or consume data to the data produced by the system, or sometimes external entities are called terminator or source or sink. Terminator means from the part of that position no data are being followed up into the next level. That's why it is called terminator. Or sometimes it is source, as user giving some input values, so it is the source. The next one is data flow symbol. Data flow symbol, the arrow sign, directed arrow sign. The directed arc is used as a data flow symbol. A data flow symbol represents the data flow data flow occurring between two processes or an external entity and a process in the direction of the data flow arrow. So it occurs between the two processes. Here should be a process or here should be a process, or between an external entity and a process, between an external entity and a process. In the direction means where data is flowing from which part to which part. If the direction is here, so data is moving from here to here. The data flow symbol are usually annotated with the corresponding data names. A directed arc or line represents data flow in the direction of the arrow. And data flow symbol are annotated with names of data they carry. So the data name should be written into this data flow symbol. Data store symbol. A data store is represented using two parallel lines. Book details here is the data storage. It represents a logical file. A data store symbol can represent either a data structure or a physical file on a disk. So a logical file and represent either a data store symbol, which can represent either a data structure or a physical file on the disk. Each data store is connected to a process. Each data store is connected with a process. That means the process stores the data into the data store, or sometimes the data store returns some data for processing to a bubble or process. A data store can be represented either a data structure or a physical file on disk. Each data store is connected to a process by means of a data flow symbol. The direction of the data flow arrow shows where the data is being read from or written into a data store. The last one was output symbol. The symbol is used when a hard copy is produced. The output symbol looks like this. Some printing materials, if necessary, then we can use these output symbols. Now, two terminology are there. One is synchronous operation, another is asynchronous. If two bubbles are directly connected by a data flow arrow, here two bubbles are directly connected by this data flow arrow. Okay, so that's why these two operations, we call it is a synchronous. This operation we call that it is a synchronous operation. If two processes are associated in single operation, then we call that they are synchronous. Asynchronous means if two bubbles are connected via a data store. That means this process stores data into this data storage, and from this data storage, this data is taken by this process. So this is asynchronous operation. The synchronization is baked by this data storage. How is structured analysis performed? Initially, we represent the software as the most abstract level, that is called context level. So when we start the data flow diagram, we have to first draw the context level, or sometimes it is called level 0 diagram. Level 0 diagram. The entire system is represented as a single bubble. The entire system is represented as a single bubble. This bubble is labeled according to the main function of the system. According to main function of the system, this bubble is labeled. So what is context diagram? To develop the data flow model of a system, first the most abstract representation of the problem is worked out. This type of representation is called context diagram. After developing the context diagram, or sometimes it is called zero level diagram or level 0 diagram, the higher level DFDs are developed. The context diagram represents the entire system as a single bubble. This bubble is labeled accordingly to the main function of the system, the various external entities with which the system interacts, and the data flows occurring between the system and the external entities are also represented into this context diagram. The data input and data output are represented as incoming and outgoing arrows. These data flow arrows should be marked with the corresponding name. The context diagram establishes the context in which the system operates, that is, who are the users, what data do they input to the system, and what data they received by the system. A context diagram shows external entities, data input to the system by the external entities, output data generated by the system. It is also called level 0 diagram. So in context diagram, there should be only one bubble. That is that whole process as a system. And some external entities or users who directly interacts with this process or system by giving some data input or by taking some data. And if there are some outputs for the system, then you should also print them, draw them into this context diagram. So context diagram establishes the context of the system, that is, it represents the system level, the data source and data sinks. Next, after preparing the context diagram, to develop the context diagram of a system, we have to analyze the SRS documents to identify the different types of users who would be using the system and the kinds of data they would be inputting to the system and the data they would be receiving from the system. Okay, so after developing the context diagram, we should develop the level 1 DFD. That is the higher level functionality of the requirements. All the activities are identified in major levels and depicts the flow of the data among them. If there are 3 to 7 high level functional requirements, then this can be directly represented as bubbles in the level 1 DFD. If the number of high level requirement is more than 7, then some of the related requirements have to be combined and represented the form of a bubble in the level 1 DFD, and some of them should be represented into the next level, that is level 2, level 3, level 4. So first examine the SRS, represent each high level function as a bubble represent data input to every high level function, represent data output from every high level function into the level 1 DFD. Next, higher level DFDs, each high level function is separately decomposed into subfunctions. Identify the subfunctions of the function, identify the data input to each subfunction, identify the data output from each subfunction. So the structure is same according to the high level functionalities, high level DFDs from the context diagram. When you decompose a bubble, that means it also called the factoring or exploring. Decompose means first time when you are drawing the context diagram, you are considering the whole system as a single process. So this single process is combination of multiple sub-process. That means the whole system is dividing into some other functionalities or modules. This is called decomposing. It is also called factoring or exploding. Too many bubbles at a level, a sign of poor modeling. More than 7 bubbles, do not create too many bubbles at a level. Not more than obviously 7 bubbles at a single level of DFD. Do not create more than 7 bubbles at any level of the DFD. Decomposition of a bubble should be carried on until a level at which the function of the bubble can be describing using a simple algorithm. So we should have decomposed each and every big processes into the sub-processes or sub-functions, and we should keep in mind that each and every level we should not put more than 7 bubbles. So here we will look the first example. The first example says that there is a software system called RMS calculating software, root mean square, RMS root mean square calculating software, which reads 3 integers in the range, 3 integers from the user in the range of -1000 and +1000, and it finds out the root mean square of these 3 input numbers and then display the output, that is display the result. So first we have to draw the context diagram. What we have told that in the context diagram the whole process, whole system is to be considered as a process. Here we are considering the RMS calculator as a process, and the user, the external entity here is the user. So to draw an external entity for user and one process as a calculator. So user gives some data, integer data to the RMS calculator. So we give the name of the data as data underscore item, data item, and the RMS calculator returns the user the actually result, that is the RMS. So this is there is no other external entities available for this program, for this problem, and this RMS calculator has to be identified by 0, or you may give the name of 1. You may start from either 0 or you may start from 1. Here I am using 0 to give the number of this process, numbering of this process.
Okay, so here the whole process is considered as the RMS calculator, and there are only one user interface, that is called the data who is giving data items to the RMS calculator, and RMS calculator returns the actual RMS to the user. So this was the main theme of our system, and this is called the context diagram. In the next step, we decompose this process into smaller processes, and we will make the level 1 DFD of this RMS. Okay. So level 1. In level 1, we decompose that RMS calculator. So how in the first step of RMS calculator was to user should give some values, and then those values are to be checked or processed that they are valid or not. So I am giving the name validation. You may change the name, but the name should be validation of input, but the name should be relevant to the program, okay, to the function. So user gives the data items, then validate the items, and then compute RMS. This is called V data, and after computing the RMS, it displays the result. That is the RMS. So this was the level 1 diagram, and we have divided the process 0 from the context diagram. That's why we give the name of the first process 0, 1, and then the next process 0.2. So this 0 means from the previous level process. This is the identification of the previous level process, and that process is divided into 0.1, 0.2, such a way. Okay, so this was the level 1 diagrams, and keep in mind that each and every arc should be associated with some data items. You should give the name of the data items and do not conflict the names of these data items. Next, we will this part is finished and this part is finished. We may decompose this compute RMS process into further. So this we will done in the second level, that is level 2. So in level 2, we will decompose the compute RMS. So to compute RMS, first user should give 3 input, say A, 3 integer input, B and C. These 3 inputs will be checked after validation. Obviously these comes from after validation, because the validate input process has been shown in level 1, and after data validation then we will get 3 inputs A, B and C. Then we make square of them. So the process name is square. And after squaring the value, suppose we get SA, SB and SC, these 3 data, and then we calculate the mean using these 3 data. After calculating mean, the next process is make the root. Okay, and the data is mean. After the root, we will get the RMS. So compute RMS has been decomposed into this 4 process. So that the name of this processes should be 0.2. It was the compute RMS process ID, and then 1, 0.2.2, 0.2.3, 0.2.4, and last one is 0.2.5. So we cannot further divide. We may also further divide this mean also. This a plus b plus c, that is the addition, and then another process divided by 3, that is the division. But this type of decomposition should not be done into the DFD, because these are the entry low level decomposition, and this type of decomposition, whatever the mean we calculate, how the calculator of mean, it is the process of algorithm. So this so we should not entitled into this DFD. Okay, so this was the level 2 diagram of our problem. Next, when the decomposition is never carried on up to basis instruction level, a bubble is not decomposed any further. That is, if it cannot be represented by a simple set of instruction. If we do that a plus b plus c divided by c, that is the simple set of instruction. There is now no functionality between that. Okay, that the combination of this instruction makes a function. That function is called mean. Okay, now we will move to the next example, tic-tac-toe. It is a computer game, and we everyone know how to play the tic-tac-toe game. Just read it out once. Tic-tac-toe is a computer game in which a human player and a computer make alternate moves on a three-crossed square. A move consists of marking a previously unmarked square. The player who is first to place 3 consecutive marks along a straight line, along a row or column or diagonal on the square, then he should wins. As soon as either of the human players of the computer wins, a message congratulating the winner should be displayed. If neither player manages to get 3 consecutive marks along a straight line and all the squares on the board are filled, then the game is drawn and the computer always tries to win a game. So here the tic-tac-toe computer game, to draw the DFD, we should first draw the context diagram at the first. This is the context. In the context diagram, we should consider the whole process, that is the tic-tac-toe whole system as a process. Give the ID is 0, and the user is player. The player may be computer, player may be human. It gives data to tic-tac-toe, and that data say some moves, and tic-tac-toe gives the player the result or display of the board and the result. Okay, so this was the context diagram of this tic-tac-toe. Now we further decompose this tic-tac-toe into several functions. And we will draw the level 1 diagram. In level 1 diagram, suppose we need to store the data on, we need to store the data in some places. That means whatever the user input was, whatever the other, suppose the data item, say we write here board. Sometimes the data, sometimes this database is shown in some books as like such a way. You may use 2 parallel lines, or you may use this type of symbol also. So the user input should be validated first. That is the validation process. Okay, so whatever the user give the moves data, that data validates first, and if it is validated, then it goes to the database. Okay, so this is the user moves. when after the user giving the first move, then the computer will display it into some computer screen. So there is a display process. We are saying that board data. This display process actually takes the data from the database and it displays into computer screen. Okay, now a computer user, here the user moves, maybe a computer user, maybe a player user, that does not depend. Now there should be another process called check winner. After each and every move, the computer should check that the game is finished, anyone is winner or not. If anyone is winner, then he will return the result. And when he checks the computer, it checks the winners, it takes the data from this database, and the data is b data. Okay, so there is another process. After each and every user process, there should be a play move process. Play move means it will move from one user to another user. If suppose one user put a cross symbol here, then the move will go to the next user, that is here the computer. Then computer put a 0 here, and this again the move will go to another user, that is the actual user player, human being player. Okay, so there should be a process. We name that process play move, and this play move takes the data from the board and gives the data to the board. It takes the b data, that user data has been inputted or not. If it is, then it will send a move data to the board. Then the board then automatically the move information will go to the user, another user. Okay, so this was the level 1 diagram, and we divided the process 0 as 0 0.1, 0 0.2, 0 0.3, 0 0.4. Okay, the order of data does not mean you may give the name 0 0.1 here, 0 0.2 here, 0 0.3 here. That does not make any problem, but try to give the name in according to the order. No problem if you change the order also. Okay, and when you will draw this diagram, any DFD, the processes should be defined from one person, may be defined from one different from one person to another person. The process name may be a little bit of different, but the name of the process should be meaningful, which is the functionality actually. And you may change this process from a little bit of changes may happen from different user of this DFD maker. Then that does not mean that that is a wrong process or that is a wrong way. You may check the validation first, then send the data into the board, and then display, then play move, then check winners. No problem. If you add more process there in and it is described into the SRS, that is not, does not make any wrong idea. Okay, now we will move for the third and last example, a supermarket price scheme. A supermarket needs to develop a software that would help it to automate a scheme that it plans to introduce to encourage regular customers. In this scheme, a customer would have first registered by supplying his or her residence address, telephone number, and driving license number. Next, each customer would register for this scheme is assigned a unique customer number by the computer. A computer can present his customer number to check out stuff when he makes any purchase. In this case, the value of his purchase is credited against his customer number. At the end of each year, the supermarket intends to award surprise gift to 10 customers who make the highest total purchase over the year. Also, it intends to award a 22 carat gold coin to every customer whose purchase exceeds 10,000. The entries against the customer number are raised on the last day. The entries against the customer number are raised on the last day of every year after the prize winners list are generated. So here there are two types of prizes are there. One is 22 carat gold coin, another is surprise gift. Okay, surprise gift calculation and 22 carat gold coin calculation should be calculated in different process. So we first calculate the we first draw the context diagram or level 0 diagram. So in this custom context diagram, thus the whole system is a single process. Supermarket price distribution. It is a 0. Whatever the users are some customer entities. He gave some inputs and got, that is the details of customer, and customer get the customer number from the user. There should be a sales clerk who gives the sale data is data to the supermarket to the software, and he should not get anything. He will only input something. According to our SRS, the sales clerk should not get anything. Okay, and there should be a manager. Manager actually generates the actual price. Manager generate after each and every year at the last day of the year what should be the prices, who should get the prices. So the data is generate prices, and after generating prices it will print a winner list. Okay, so this was the level 0 structure, level 0 diagram of our system. Next we will move for the level 1 diagram. Then we decompose the main process into some sub processes. Now level 1 diagram. In level 1 diagram, we need to store the customer data into a database, say cust info, or cost data. Another is say sales info or sales data. Now the customer, that is gives the customer details. Whatever name we have given to the previous level 0 diagram, that name should be the input here. Do not change the same thing name in different way. Registration process. So in the registration process, customer gives the details, it stores into the say C details, it stores into the customer info. Okay, and Then there is a sales entity, salesperson. I think the name it was previously. So no, sorry, this salesperson is no need to showing again. We just take the data whatever the salesperson is. So that is the sales process. It gives the sales data. Okay, you should not expect anything. And there is another process, that is manager, who generates the winner list. He gets data from customer info, he gets data from sales info, and he gives the winner list. WINNER winner list. So C data, and this is S data. The numbering should be 0.1, 0.2, 0.3. So this was the normal level 1 diagram of our problem. You may further divide this generate winner list into some more processes. So here it is 0.2 process. We will further divide this 0.2 process into level 2 diagram. So level 2 diagram. In level 2 diagram, we take a process to calculate the total sales, and this total sales take data from the sales information. Sales কি নাম ছিল? Info, most probably, and another was customer info. So from this total sales is data. From this total sales process and this customer info process, it will calculate the surprise gift. Process. Customer C data. So surprise gift process gives the winner list of 10 winner list. Okay, first 10 winner list. There is another process, that is the gold coin gift. It takes data from the total sales and the customer info, that is C data, and it gives the name of the winners, greater than 10,000. Okay, so 0.2 has been divided into 0.2.1, 0.2.2, 0.2.3, this. So this was the actually level 2 diagram. Here we divide the whole process into we calculating the total sales, and after calculating this sales we take this data and customer info and comprises the surprise gift result, and it will return our 10 winners. And by calculating this total sales, and from that three data we calculate the gold coin gift result process, and this process will give me as the winners of get the total 110,000. Okay, so this was some examples. I will say that you follow some more examples into the whatever you can get, and then it will be better understand to you if you practice it. But no need to necessary that each and everyone's each and everyone's DFD should be same according to the process name, according to the process, etc. Thank you.